Hey everyone, welcome to our first official video of the semester. This video is going to be over section 1.1, which is all about vocab. I did post an intro video on Edpuzzle that should help you understand some of the stuff we're going to talk about here. But like I said, this section is all about vocab, and vocab is absolutely critical when it comes to geometry. You will not be successful in this course if you don't learn the vocab. With that said, I want you to take a second and try to remember back. You've learned all these at one point in your mathematics career, but try to remember back and see how many you can get on your own, and then we will go over it. All right, guys, let's check to see how you did. So a three-sided polygon is called a triangle. Hopefully you guys got that one. Four-sided is a quadrilateral. Five-sided is a pentagon. Six-sided is a hexagon. Now, the way I remember that is 6 has an X in it and hexagon has an X in it. So if you pair those two X's, you know they go together. Seven-sided polygon is a heptagon. Eight-sided, our stop sign, is an octagon. Nine-sided is a nonagon. The way I remember that is 9 has two ends and nonagon has two ends. Number 8, a 10-sided polygon is called a decagon. 11-sided is a hendecagon. And then a 12-sided is a dodecagon. So if you don't know those or if you don't remember them, please do. All right, now on to some more vocabulary. So points, lines, and planes, which is on this slide, that's the kind of the big topic idea of that intro video that you should have already watched. So now I just want to put it into words. But before we can put those into words, we have to talk about what an undefined term is. Okay, undefined term is just a word where there is no formal definition. However, there is an agreement about what it means. So in other words, we don't have words to define an undefined term, which makes it so complicated, which is kind of why I gave you that video. But a point is one of those undefined terms. And the purpose of a point is it gives the exact location of something. Okay, now a point is represented by a dot with a single uppercase letter. Okay, now a line is also an undefined term. And it represents a one-dimensional straight line, whatever, come back to the undefined term. It is made up of an infinite number of points. And it extends without end. When I say it extends without end, that means it goes on forever and ever and ever. Now, lines are written with a double arrowhead, so like this, over two capital letters. And it is sometimes, you can also see it written as a single lowercase letter. And we'll see that more when we move more throughout the semester. All right, so last one on this slide, a plane is the third undefined term. And it is now two-dimensional, so up, down, left, right. It's usually shown as a flat shape resembling a floor or wall, and it extends without end. So it goes on forever and ever and ever. Now a plane is usually written as either a single uppercase letter, and this is generally in the corner of the plane. Now we'll do an example where I'll show you. Or as 3 non-collinear points. And this is what they talked about in that video before. Now if you're thinking, what the heck is non-collinear, we'll get there here in a couple of slides. Okay, let's move on to some defined terms. Now, defined terms are much easier to define because they are words that can be used using words that we know the definition of. So words that can be defined using known terms. An endpoint, as you could probably guess, keyword end, is a point in which a line, ray, or segment ends. Okay, so say we have this segment, AB here. So here's A, here's B. Both A and B would be endpoints because that's where that segment ends on either end. Okay, so that's what an endpoint is. So recall back to the video, the first video you watched. A segment is a line where both ends have an endpoint. Okay, so this here, this AB would be a line segment. It does not go forever in either direction. All right, now segments, guys, they are represented by a single line. So I'm just going to do that over 2 capital letters. So if I wanted to name this, I would write segment AB with a line over top. You do the line so you know it's a segment. Or since they both end at A and at B, you could write this as BA with a line over top as well. All right, now on to rays. So a ray is a line with an endpoint on one end and extends without end on the other. So it starts at one side, starts here, and then it goes on forever in this direction. So say this is C, D. Okay, so here's our endpoint, right? The C is an endpoint. D is not an endpoint because it keeps going. Rays, they are represented by, I'm just going to put the arrow, single-sided arrow over 2 capital letters. Okay, so if I wanted to name this ray, I would name it CD with my arrow. Now, when I name these, this first letter here is always the endpoint. Okay, and this arrow is always pointing right. So we could not write this as DC. All right, now let's talk about opposite rays here. Okay, opposite rays would be 2 rays that start at the same point and go off in exactly opposite directions. Okay, so I've kind of pre-drawn these opposite rays. So an example would be something that looks like this. Okay, so I could say that ray AB, don't forget your ray symbol over top, so ray AB would be start at A and go through B. So I could say ray AB and ray AC, don't forget your ray, would be A to C this way. Those would be opposite rays. They both start at the point A and they go off in exactly opposite directions. All right, now if I look at the second one here, notice that they both start, so if I had like AB, ray AB, and ray AC, okay? They both start at point A, right? But B and C are not in exactly opposite directions. So B is kind of up and to the right and C is more downward, okay? So that would not be an example. Another example over here would be like AB. So I could say ray AB, don't forget your ray symbol. And I don't know, let's do BC. BC. Some of you are thinking, why not? BC is this, right? All the way there. Well, the reason those aren't is because they don't start at the same point. Okay, they have to start at the same point and go off in exactly opposite directions. All right, so intersection, you should have heard this before. It's a place where 2 or more geometric objects meet each other or cross each other or connect to each other, whatever you want to say. 2 things that are coplanar, they share the same plane or they lie on the same. Now that we're done with vocabulary, let's look at example 1. So A says, give 2 other names for PQ. Now notice this double arrow over PQ is talking about this entire line going up and down here, okay, with P and Q on it. So it's this whole thing here. All right, so we could label this as QP, and don't forget your double arrow over top. If you do, it's wrong. But also, notice over here, Notice the small n. That's also the name for the line. Remember we said in our vocab that sometimes lines are named with one lowercase letter. So there's two other names for PQ. All right, now name two other names for plane R. So when I look at this, I notice R in the corner, and some of you are probably wondering, how do we know that's the name of the plane, not a name of the point? Well, there's no dot that goes with the R. That's one sign that it's not a point, but the other is, usually when it is the name of the plane, it's embedded in this corner right here. So that is the name of this plane. So all we need to do here is we need to find, remember, we have 3 points that we need to name the plane, and those 3 points cannot be in the same line. Okay, so we can name it, let's name it plane VT, I don't know, P could be one. Or we can name it plane, I don't know, SPV. What we can't use is we can't use the small n because that's the name of a line, not a point. We can't use small m because that's the name of a line, not a point. We can't use capital R because that's the name of the plane. We can't use point Q because that's not on the plane, that's above the plane. And we can't use the combination of SPT because those are all 3 in the same line. All right, name 3 points that are collinear. All right, so keyword here is collinear, and you should know that collinear means on the same line. So if we look up here, there's only one set of 3 points that are on the same line, and it's right here. So we could say S, P, and T. Oh, sorry, S, P, and T. Name 2 sets of 3 points that are coplanar. Well, guys, these are coplanar, right? So let's just use those. That'll make it easy. So VTP is one and SPV. All right, let's look at example 2 now. All right, so A says, give another name for segment KL. We know it's a segment because there's just a line over KL. That means it starts and it stops at K and L. Okay, so the only other name we could have, the only other thing we can call that starts and stops at KL is LK, and remember, we keep the line over top, otherwise it is wrong. All right, B says our KP, so KP, ray KP, so it starts at K and goes towards P forever and ever and ever, and PK, ray PK, so it starts at P and goes towards K forever and ever. Are they the same ray? Well, as you can clearly see when I drew it, they are not the same ray. So no, and the reason they are not is they start at different points. Or you could also put they go in different directions. Okay, let's see if we can't figure out how to erase this now. There we go. All right, so part C says, name all rays, or sorry, are ray NP and ray NM the same ray? So ray NP, so starts at N, goes forever to P, and then ray NM starts at N and goes forever to M. Are they the same ray? Well, these two are, yes, because they start at the same point and they go off in the same exact direction. So I'm just going to put by definition, okay? Because the definition says they start at the same point and they go off forever in the same direction. All right, last but not least, name all rays with endpoint at P. So we have PN, because that would be from P to N. We would have PK, that would be from P to K. We have PM, that would be from P to line M. And last but not least, we have PL, that would be from P to L in the same exact direction.